So let's write now electromotive force of a battery. Electromotive force of a battery. Okay, so if suppose we make one simplest of circuit, in this one resistance is there and there is a battery. Okay, battery is there. Now we all know that these are connecting wires, these are connecting wires, these are connecting wires. Their resistance is almost zero. We don't consider they have resistance. So what will happen? If I consider here potential zero, then here zero, here also zero, here also zero. Here zero and here zero, that means current will be there or not? Because for current, potential difference is required. Current is there. Okay. Because V basically is what? I into R. Because R is zero, V is becoming zero. Or potential difference is becoming zero. Okay. Current is there. Current is not zero. Resistance is zero. Okay. So in connecting wire, yes, here and here there is no potential difference. It is because resistance is zero. So current is there. Okay. Here is what potential? Here potential is V. So here is also V, here is also V. The same case here also. Okay, potential difference is zero. It is because resistance is zero, right? So potential difference across resistance is what? V. So current is what? Current is V by R. Because current is potential difference by resistance. Current is moving like this. Right. Now if we talk about battery, this is battery. This is its positive terminal, this is its negative. Now in this direction over here, current is coming. Now current is coming means I can say positive charges. Let's assume that opposite of electron, positron is there. Why? Why we are taking positron? Why not electron? Because it will be convenient for us to take the direction of current itself. Electron means it's opposite direction. Okay. So current is coming like this. So we are saying that okay. So positron is coming. Okay. All right. Then this positron enters into negative end. Negative end of this terminal. Now what will happen? Because we know that the current comes over here, the same current has to come from here on, then only this will be keep on moving. If suppose this is the fan has to run, current has to be coming to this one continuously, then only it will, because current basically is what? Current is an agent which is carrying energy, which is giving energy to this appliance, and if this appliance is running, the continuously current has to come. The current which is coming over here, same current has to come over here. There should not be any decrease in the value of current also, right? So what happens is, if this positron is coming over here, that positron has to come over here then, right? Then what? If this is a battery, we know that this is positive terminal, this is negative terminal. So there will be electric field in this, and this electric field is always from positive terminal to negative terminal. Like this will be electric field. So if this positron is here, on this positron, we know that there will be force acting in this direction. It will be E into E, that will be force due to electric field. Because on positive charge, it will be in the direction of electric field. Then how it will come in this direction? Because electric field is acting in this way. Then how this positron will reach to this positive field? Battery is working. In this direction, battery applies the force. Okay. So this will pull it in this direction, opposite to the electric. Okay. So this work done by a battery in moving a unit positive charge from negative terminal to positive terminal. Okay. Negative terminal to positive terminal is called electromotive force. EMF is actually not a force. It is potential difference. Work done per unit charge. Okay. What is it? Work done by a battery in moving unit positive charge from negative plate of the terminal to positive plate of the terminal. It's called electromotive force. Okay. In some books, it is given in different way. They say that work done by battery to maintain the potential difference of the battery is EMF. That is also okay. Why is that okay? Because if I assume that this positrons are coming in this one onto the negative plate. So what will happen if the positives are coming? Its negativity will decrease. When its negativity is going to decrease, that means its negative potential is going to decrease. Same way, from here what is going to happen then? If these positive charges are not reaching over here, its potential start decreasing because it will have less positives. Okay, so its potential will start decreasing. The potential difference also starts decreasing. So battery does work to maintain the potential difference. That is electromotive. So there are two types of definitions. Okay, so what is our definition? work done by battery in moving unit positive charge from negative terminal to positive terminal. Okay, since it's work done per unit charge, so its unit is volt. Okay, its unit is volt. So EMF's unit is volt, as it is work done per unit charge. Okay, note that.
Yes, sir.
Okay, so now this V, is this V EMF or not EMF? Let's see. This EMF of battery we represent as is represented as like this. This is EMF. Now the question is this EMF equal to V that we are getting, that we are using every time that we are writing battery, we are writing V. So this V is not EMF. Okay, this V, potential difference across battery, V is not EMF. And what happened now? Why it's not EMF? Because EMF unit is also volt and this is also volt only. So V is basically the energy that we are getting. V means the appliance. And EMF is the work done by the battery in moving the charge inside. Both are different. Okay, what is V? V is the energy received by appliance. That means output. Output of battery. Then EMF is what? EMF is input. That means output is not equal to input. Why? Because there is some opposition even inside. Other than electric field also there is opposition in the battery. Now who's opposing? Because in the battery what is there? Electrolyte is there. Okay.
Internal resistance, sir.
Sorry?
Internal resistance, sir,
Yes,
inside
we show
battery.
that as internal resistance. Basically, there is internal resistance we show in our circuits like same way as we show the external resistance. But actual meaning is it is the opposition created by the electrolyte in the motion of charges. So other than electric field, okay, battery has to work in overcoming that resistance of electrolyte also. Okay, so we don't get the entire work done by the battery against electric field. Okay, that much energy, some amount of that energy also is getting consumed in electrolyte work. So that we call as internal resistance. Okay,